All right, good evening, everyone. Good morning, good afternoon, depending on where you're joining from. Happy to have you guys here again. You're welcome to class 4 of software development DSA course. Good to have you here. Please kindly confirm that you can all hear me and that you're set for the class as well. And if you can as well, you can type where you're joining from. I would like to know where we all are joining from tonight. All right, great. Thank you, Moses Blaze. You can hear me loud and clear. So I do believe that the first week went well, and we did gain some few lessons from the first week. So you're welcome once again to the software development class, and this is week 2, and this is the 4th class. We had 3 classes last week, and this week as well we'll be having 3 classes. And like I mentioned last week, yes, we started on a Monday, but from here on, our class we start Tuesday, and then we have another one on Wednesday, and then on Friday. So we have people joining from Alta, Ogun State, and we have Oluwatoyin Aluko from Alta, Ogun State. We have Osakwe from Lagos, and we have someone joining from Ghana, Accra. That's nice. Joining from Abuja, from Osun State. All right, that's great. Also, kindly let us know that so far you've been enjoying the class. You can give a thumbs up if you've been enjoying the class. And also, I want to remind us, if there are any questions that you want to ask, do feel free to drop it in the chat section, and during the class I will get to it, and as much as I can answer, I will try to answer. All right, good evening, good morning, and good afternoon once again. So last week, I'll try to do a recap for last week. Last week, we looked at introduction to software development and software development life cycle, that's LSDLC. And we also looked at software development methodologies, where we looked at Agile, Waterfall, and DevOps, and so on and so forth. Okay, as a way of giving us information regarding the class, so going forward, we'll be doing a weekly assessment to help you crystallize the information you're getting from us. And that assessment will happen every Friday. So we'll provide you with a link for you to join, to take the assessment. I think we will start with Google Form quiz for now. And if there will be any changes along the line, we will also communicate that. So once you're given the assessment, you'll have a whole week to attend to the assessment. So the questions will be from the classes that holds here. I mean, they won't be difficult questions really, but just based on what we teach in the class. And the whole point is for you to gain better understanding of the information you're getting. And we also want to be sure that beyond the class, you're also doing some readings as well. All right, again, you can ask questions in the comments section, and I will get to them once I'm able to. All right, Josephine Odukoya said the classes have been wonderful so far. So that's great to hear. All right, this week we'll be doing an introduction to programming languages. I know that we all have been eager to get to the point where we start writing code. So I believe that this week we actually get our hands into writing code. So you may have the question that how did we go from introduction to software development to talking about programming languages? In software development lifecycle, which generally speaking, we can look at as a journey. In my class, I did talk about it as being a journey. So you start from discovery phase to the design phase, and then you get to develop, test, deploy, and then you start gathering user feedback. So this is the journey as I described it in the first class. So starting from discovery, design, then develop, then test, then you deploy what you've programmed, and then when people start using it, you also start to get to gather feedback from the usage. All right, great. So your programming skills will come in handy at all the stages, but more importantly at the develop, test, and deployment phase. This is where what you learn in the programming class will really become handy. When you are developing, you'll be developing with a programming language. When you are testing, you'll be using a programming language to also write your test. And also in deployment, when you're doing CI/CD, or if there's any workflow you are orchestrating, most definitely you'll be using a programming language to do that. So that is why we are starting programming language this week. All right, I see a bit of engagement in the comment section. Yes. All right, okay, so let's get into today's class proper. So we are looking at introduction to programming language, and I think starting with a bit of definition will actually help. The first definition we may want to look at is what is programming. What is programming? So programming is the process of giving instructions to a computer so that it can perform tasks. So when you are programming, you are giving instructions to a computer, and you are telling the computer to perform certain tasks for you. That's essentially what programming is. I mean, you're trying to get a computer to do something for you, and you're giving it instructions that it actually understands. So what then is a programming language? A programming language is a formal language, and I'd like us to pay attention to the word formal language. It comprises a set of instructions that produce various kinds of output. So a programming language is a formal language comprising a set of instructions that produce various kinds of output. All right. So then the question will be, what do we mean by formal language? But before we get into all of that, maybe I'll do a quick run through of what to expect for the class and what our learning objective will be today. So today we'll be covering what programming language is, and I already gave a bit of definition to that. So we'll look at what is a programming language, and then the evolution of programming languages, then choosing a language to program with, like what are the decisions that you have to make when choosing a programming language to learn, or when choosing a programming language to use for whatever project you're working on. So we'll look at that as well. And then we'll look at core building blocks to a program. As of today, there are about 8,000 plus programming languages. And you may begin to wonder, where would you start from if you're to learn coding? Are you going to learn everything? Definitely not. But thankfully, there are constructs in programming languages that tend to repeat itself depending on the type of programming language or the class the programming language belongs to. So we will look at those recurring constructs that you get in a programming language today. And then we'll briefly look at how programs are run. So you've written the code now, how do you run the code that you've written? And then we'll do an overview of different programming paradigms. And we'll get to understand what paradigms are. All right. So the learning objective for today's class, we are looking to define variables, functions, loops, and conditional statements, and that we'll consider when we get to the building blocks of a program. So by the end of this class, you should be able to identify what a variable is, what a function looks like, and what a loop looks like. And why do we need a loop in a program, and then what conditional statements are. And also you should be able to, at the end of this class, write a simple program using this construct. Yes, it may not work well yet, but just put something together based on what construct you are learning, or you're going to learn in this class. And then lastly, you should be able to recognize syntax patterns across multiple languages. By the way, in today's class, I'll be showing you example code from Python, from TypeScript, from Java as well. And the reason why I'm mixing all of that together is to also establish to you that there are actually constructs in programming languages that you find across different programming languages. So if you have PHP, if you have JavaScript, if you have Python, if you have Java, you get the same construct all the time. All right, so that's why I'll be showing you examples from different programming languages. So we already covered what programming is, but just to restate, programming is giving instruction to a computer so that it can perform tasks for you. And what is a programming language? Like I mentioned earlier, that you should pay attention to the word formal language. So a programming language is a formal language comprising a set of instructions that produce various kinds of output. So a formal language comprising a set of defined instructions that produce various kinds of output. So by this definition, you may ask yourself, what does it mean when we say a language is formal? What do we mean when we say a language is formal? We are essentially saying that there are strict rules guiding the language which you have to follow or which you have to abide by, right? Take for instance, English language, for example. There are many ways you could communicate that you are hungry, for instance. You can say, oh, I'm famished, or you can say, I'd like to eat something. English language is a natural language, not a formal language. I mean, in the sense of classifying languages, a programming language will be termed to be a formal language because of the strictness of the rules that guides it, or the syntaxes that guides it. And the fact that there is no ambiguity when it comes to a programming language. Whatever it is that you write in your code, whoever reads it, they almost immediately would understand what you're trying to do. But again, given the example of someone trying to express the fact that they are hungry and they are saying it in English, someone might say, oh, I'd like to eat something, or I'm hungry, or I'm famished, or I'm developing an appetite for what you're cooking, or you did not say, come and eat. Are we quarreling? I mean, for us in Nigeria here, you probably have heard someone say that, you didn't call me to come and eat. Is it that we are fighting? Essentially, the person is trying to say that they are hungry, but expressed in different forms. And that's where the ambiguity comes into play when it comes to natural language. But computers don't deal with ambiguity, right? A computer wants you to be clear in the instruction that you are giving to it, and hence the strictness in the syntax of a programming language, and hence the reason why we call them formal languages. I mean, you can literally call them mathematical function if you can, because giving it the same input, you definitely are expecting to get the same output, right? So it feels very mathematical when you're writing code. I mean, really, it is mathematical, because again, when you say, for instance, if 2 is greater than a particular number, do this. For any time 2 is greater than that particular number, the next set of instructions will always be carried out. So you are sure that, okay, for as long as 2 is greater than x, this instruction or this next line of code will definitely happen. And mind you, computers only understand formal languages. And you may want to say that, okay, but when I go to ChatGPT and I type something, it understands. So a computer does not understand in that sense what you are asking it. Even though it might seem like it, underneath that intelligence that seems like, oh yeah, a computer can interact with me, is a series of mathematical representation of natural language. Essentially, your natural language, be it English or whatever local language you speak that you're using to interact with ChatGPT, is being transformed to a formalized format. So GPTs, they vectorize your prompt. So as you're typing into ChatGPT, it vectorizes it. It changes it to numbers, right? And then in the background, the GPT works with those numbers and then provides a response based on what it feels is statistically likely to be a good response. So it's converting what you're typing to numbers and then comparing those numbers to what it has been trained on. And then it will give you a response based on how close your prompts are to what it has been trained on. Yes, it has been really good, but at the end of the day, it is still numbers. So you give English to ChatGPT, it turns it to numbers, vectors. Then it calculates relationship between those numbers and then turns the numbers back into English as a response. So essentially, what I'm saying is that computers don't understand natural language. It only mimics understanding it. So it only models patterns based on a statistical relationship between the vector that it generates from the prompt that you are giving it and the vector it has learned during its training. So what am I getting with this? Where am I getting with all of this that I'm explaining? Because computers can only understand formal languages, then we have to learn the language that computers speak. That's the only way you can instruct a computer to perform tasks. You have to speak its language. And like I said earlier, there are several thousands of programming languages out there. But thankfully, some of them have similar patterns. So once you learn your first programming language, it becomes a lot easier to pick a second one. So with your programming language, you can make a machine or a computer do a repetitive task at very high speed. You can make it automate complex logic, such as booking flights, building a website or interacting with the website, or banking, right? And then you can build apps, games. You can even build your own AI model for as long as you understand the technology behind it and you are rightly equipped with the right programming language. So now I would like us to look at the evolution of programming languages, and this will better give us a background to how the programming languages that we have today came to be. But before we do that, I'll go through the chat and see if there are questions from you. All right, I can see that people are taking notes. That's nice. Okay. All right, I do not see any question yet. So nice. I believe we are all following the class. So evolution of programming languages. Evolution of programming languages. So we started in the era of machine instructions. So essentially, a programmer is talking in ones and zeros. So that was in the early 1940s, right? So the only way for you to interact with a computer would be to write ones and zeros, because essentially that's how a computer communicates. When the transistor that is in the computer is open, it is taken to be in a on state, and when it is closed, it is taken to be in an off state. So that on and off state is represented by a 1. When it is on, it is a 1. When it is off, it is a 0. So it is the combination of those, or let's say a permutation of on and off states of the different transistor that you have in a computer that executes the code that you are writing. So essentially, as far back as 1940s, if you were to be a software developer, you'll be writing codes ones and zeros, right? And you can imagine how extremely hard it would be to read, because you just have a bunch of zeros and bunch of ones, and if you're not an expert and if you're not highly talented, you would hardly be able to make sense out of those numbers. So in this era, people had to think like machines to make computers work, right? They had to think like a machine, essentially. Then we got into the era of using assembly language. So this was a tiny step towards using words like we have today. So it was short, it was human readable. Then they were using mnemonics so that they can easily remember rather than cramming ones and zeros. So essentially, the ones and zeros that you had in the early 40s were converted to like, say abbreviations, but mnemonics is what they call them. So you can have something like move 2 to A, where 2 is a value and where A is representing a location in the memory of the computer, and move is the instruction itself. All right, so still painful to write assembly language. Well, for me, from experience, when I was in the university, we did assembly language then. Yes, it was understandable, but it was too low level in that you have to understand how the hardware works. You even need to understand what instruction set those hardware came with. And to imagine the different kind of computers that we have today, different type of architecture, different manufacturers, and then you have to memorize and know all the instruction sets that those hardware comes with before you can write a program. Imagine how difficult that would be. So it was still very low level and close to what a machine might understand than what human beings could easily decipher. But at least we can say that it was still slightly close to human thought. Then we came into the era of high-level languages. That was in the 50s to the 70s. And what characterized high-level language was that it was a lot closer to human language. So then programming languages became a full English-like syntax for the first time. So you can actually give an instruction like, oh, do this, while this, or jump, or exit here. I mean, it felt as if you were speaking English. This was also the era when abstraction began. And in this era also we had languages like Fortran, which was deployed for science and was very math heavy. So if you're doing anything science related, you would most likely do it with Fortran. And also in this era we had COBOL, right, which was targeted at business application. And we had Lisp, which was used for symbolic AI programming, even as far back as the early 50s and 70s. So AI has actually been around. Yes, it's booming now, but it's not a technology that just came by yesterday. It's been around. So in this era now, people can think more about the problem they want to solve instead of thinking about how the hardware works underneath. Now they have the ability to program much more complex program or write much more complex software. Then we came into the era of structured programming. And by the way, I'm saying all of this because, yes, some of these programs, programming language still are around, and it will better give you a good context as to where they came from, how they came to be, and then give you a better appreciation for the programming languages that we have today. So around the 60s and the 80s, in between that era, was when structured programming languages came about. And in this era, people now could organize their thoughts because it was a lot structural. That was the time constructs like looping, conditionals, or functions started. And then, well, we'll talk about all of this much later in the class, but in that era was when the C programming language really became popular, and people were building bigger programs that were much more safer. And it was a lot safer because a lot of abstractions had happened at this point. Now you're not really interacting directly with the hardware, where you could easily make a mistake and destroy a computer because you were interacting with a computer memory directly or interacting with an hardware directly. But at this point, a lot of abstraction had happened, so it was a lot safer to write codes without breaking a computer. And then we had the object-oriented programming languages coming around 1980s and the 1990s, and this era afforded us the ability to think in objects. So now you can model real life in a software. So you can write a code for a person, representing a person, and a person can have ethnicity, a person can be married. I mean, you can model real life objects with these programming languages. We also look at that. I have a code snippet to describe what object-oriented programming now looks like. In this era was when we had C++, then we had Java, and Python also around this era adopted object-oriented concept. We had many other languages in this era. We had C++ also in this era as well. So all of this advancement actually allowed for massive systems. So it was around this era that you started having operating systems and banking software, and also around this era was when web application also began to boom. And then that leads us to the web development era, which also gave birth to a lot of, or let's say made popular some programming languages, and also gave birth to some newer programming languages as well. Around this era was when we had PHP, and also Python became much more popular around this era, and other programming languages that were targeted towards building for the web, like JavaScript and Ruby and all of those came around those eras. And now we have the modern era, which started from the 2010s, and we have that till today. Now we have programming languages that target different paradigms. We also talk about paradigms much later in the class. So you have a programming language that can do functional programming, that can do object-oriented programming, that can do procedural programming. Around this era, we have Rust, Go. So all of these languages, we can actually say they matured to give us better safety while making our life easier. So the things that we needed to tend to before with much older programming languages, we now do not bother about them. And they also afforded us better speed as well. Now you can also write concurrent codes, so different aspect of your program running concurrently, as against your program being executed line by line after the other. All right, so that's that for the evolution of programming. And then looking into the future, yes, there's an AI boom, and what we are hoping would happen is that we'll be able to code as easy as talking. Yes, there's a similitude of that happening right now, but we still have quite a bit of journey to actually get to the point where you say to a computer with your natural language, even probably code with your local language. But we are looking forward to that future. We know it's around the corner and we are keen to see it. All right, so let's look at how to choose a language to program with. And I'm going to address this from two different perspectives. So for you as a beginner software developer, how do you choose? How do you pick a language that you want to learn? Let's say your first programming language, how do you make that choice? There are a lot of factors to it. So picking a language is based on quite a number of factors, and we will look at some simple reasons behind some choices that we make when we pick a programming language. And again, remember there are about 8,000 plus programming languages in existence. And by that number, it is practically impossible to learn all programming languages, and nor do we have the luxury of time to test all programming languages until you are sure which one fits you. But there are some languages that have become like an industry standard for different domains of software development. So talking about games, if you want to build a game, or if you want to write a program that will be used in the bank, it has gotten to the point where you can easily say, okay, this is a go-to language for this, or this is what is popular for this kind of code. So in picking a programming language, especially for those who are just starting, you might want to consider your goal. And the goal that you are looking at is also intertwined with how you want to build your career, in what aspect of software development you want to build your career. Do you want to become a game developer? Do you want to work with blockchain technologies? Or do you want to build for the web? Do you want to do mobile apps? Or do you want to build desktop apps? All of that will help you in deciding what programming language to go with. And also another thing to consider is the ease of learning. There are different programming languages and they all have different learning curves. Some are difficult sometimes, depending on the person. For me as a person, when I started learning HTML, you may say HTML is really, really simple. But when I started learning HTML, it didn't make so much sense to me until I forcefully started building something. Even when I started building something, it still didn't make a lot of sense to me. The most I could do was probably change the background color of a website, and that was the most I could do until eventually all of it just made sense to me. So what I'm saying in essence is that different programming languages have their difficulty levels, and also depending on you might at some point find a programming language challenging at first. But all of this ties into how you choose a programming language that you now settle for to start learning with. For some people, they quickly grasp the idea behind Java. They quickly understand object-oriented programming, and for some people, they find it weird when you ask them to write a Python code, especially when you're not using object-oriented programming. They find it weird to understand functions or to write procedural codes. So all of this, you get to choose based on what is easier for you to learn. And again, most programming languages are alike, so choosing the first programming language shouldn't be too much of a big deal, because once you can learn the first one, it'll be easy to transition to the other programming languages. And then another thing you might want to consider is what community and ecosystem exist for that language that you are trying to learn, right? So take for instance COBOL. I did mention COBOL, which came to be around the 50s and 70s. And we still have programs running on COBOL till today, right? But imagine you just starting out your career. You're just starting out your career and you want to learn COBOL. Hardly will you find people who you can easily run to when you find challenges down the line. I mean, I can remember a friend of mine was able to reach out to me on issues around JavaScript, right? If there were not a lot of people around that I could have reached out to, then it becomes harder for him to actually progress in learning JavaScript, right? So you have to consider the community that exists. And by community, I mean the people that are around using the same programming language, the tools that have been built for that programming language. Then the ecosystem will be what tutorials, for instance, exist, what packages exist that have been written. I mean, all of that ties into how you make your decision around picking a programming language. All right, so I'll pause a bit here and I'll try to look at what we are saying in the chat. If there are any questions. Okay, I think there's a bit of chat that has been going on, so I'll try to scroll up to see if there are questions. I think someone is asking about what ID. So last Friday we recommended that you install VS Code, although the next class we actually dwell more on that topic, talking about ID, and in that class we help you through the process of actually setting up an ID for yourself. So you can use VS Code, you can use Sublime Text. I think those are quite standard. And VS Code is quite matured now, that especially if you're targeting web, I think VS Code is a good choice to go with. All right, I'm still going through our questions. Yeah, someone has a concern about the practicality of the class. Again, like we said, just hold on. We want to cover the theory as much as possible. And like I also said, it's a lifelong journey to become a software developer. Yes, you might be eager to jump right into coding. And if you don't understand the basics, that will be much more frustrating than whatever theory you're learning now, which you might think is boring. At least we have had experiences. I've been doing this for close to 10 years now. The times that you feel like hitting your head against the wall is mostly because you fail to understand the basics or the theories behind the things that you're doing, and then you're forced to go back to learn. And while learning and you are still under pressure to deliver, that's when programming becomes hard. So we definitely understand that from our own experience, and that's why we're trying to cover as much on theories as possible. And again, it's 3 months. We want to try and expose you to as much as possible so that beyond the 3 months, you have a good footing to actually continue learning by yourself. Someone is asking how long does it take to make an app? It's depending. If it's a simple to-do list app, it can take you a week or less. All right. If I miss your question, it wasn't intentional. I'm just trying to skim through as fast as possible. All right. Okay, I think that's that for for the questions. If I miss your question, you can retype them again, and the next time I go through questions, I will get to them. Someone is asking, so why do a lot of programmers not consider HTML a programming language? Well, by the definition of what a programming language is, HTML is a programming language because you can use it to instruct a computer what to do. Fine, it's not functional as such, but it belongs to a class of programming language that we call declarative. So you declare what you want, and then you get it from the computer. So yes, HTML is a programming language. Yeah, but fine. A lot of programmers will say, "Oh, it's not a programming language because yes, you can write functions, you can write classes and all." But again, by the definition of what a programming language is, we can consider HTML to be a programming language. All right. Someone is asking about object-oriented programming. Okay, maybe I won't spend a lot of time on that because there's a class for that specifically. But let me just explain that again. So it's a programming paradigm, and the paradigm actually tries to model real-world objects. You know how you have a car, and a car has a tire, and how a car can drive. All of those things are like attributes of a car, but those attributes are not just peculiar to a singular type of car. Yes, you may have a Mercedes-Benz. The Mercedes-Benz has tires, can drive. So also is with a Toyota Camry. It can drive, it has tires. So with object-oriented programming, you can model, for instance, a car. And a basic car is expected to drive and have tires. So that modeling ability that you have with object-oriented programming actually makes solving some real-life problems a lot easier, because now you can describe a human being to have a name, to be able to talk, to have a house, and so on and so forth. It's just a programming paradigm that closely tries to model real-life objects. And the essence is actually to be able to build much more complex software that is as close to how we reason as human beings as possible. All right, so I was saying that it depends on your goals when you're making a choice of programming language. It also depends on the project you are trying to build, right? That determines what type of software, what type of programming language you choose. If you are going to be scripting, then maybe Python is best for you. If you're going to be building a website, you might want to reach for Ruby on Rails as a framework. You might want to use PHP, right? And I think a lot of AI programming revolves around using Go now, Golang, and Python. Python is quite popular, and yeah, so all of that might inform how you make a choice. So your first step, if you're just starting out, is to pick one goal. What do I want to do? Yes, I want to build websites. So if you're building a website, you know that you will learn JavaScript because you can't really escape it. Then commit to that language for 30 to 60 days, for instance. And there are various challenges that you can actually join. There's 100 days of JavaScript that you can join online. There is 100 days of Python. All of this is to help you gain solid ground and solid understanding of the programming language of choice. Okay. And then try also to join communities. There are communities on Twitter, on Reddit, on Discord. You can join a Discord server to also learn from others. Even on GitHub. Yeah, we'll talk about GitHub in details in a later class. so that we understand what GitHub is used for and how you can benefit from using GitHub, right? And also try to build small projects as you're learning, because you don't want to be stuck in a loop where you're just learning and learning and it feels like you're stuck and you're not able to build anything. And stick with that language for as long as possible until you become comfortable with it. Okay, so now let's jump into the next outline for today's class. We've talked about choosing a language. I did talk about if you are focusing on web development, that would inform the languages that you use. If you are going to be a data scientist, for instance, or AI or ML, then you choose a language that is already established for those type of software development. All right, so choosing core building blocks to a program. I did mention earlier that for every programming language, there are constructs that are similar that you come across all the time. One is variable. You always have to declare a variable. I will describe to us what a variable is. You have operations that you get to perform, data types, control structures. I mentioned earlier what control structures are, where you have conditionals or loops, and then you write a function, then you have to deal with data structures, then input and output, comment, classes and objects, modules and libraries, and then how to handle error. So in this section, I'll provide us with code snippets from different programming languages. And again, it's to establish the fact that all these constructs that we are talking about actually cuts across most programming languages, especially those that belong to the same class, right? So variables. Variables are one of the most fundamental building blocks in programming language. You will always have to write or declare a variable. And what does it do? It serves as a container that holds a value, allowing you to be able to store them or store information in them for you to be able to reuse them for a later time. So if you look at the code example that I have below, which is a TypeScript code, we are declaring a name. So we are saying let name. And if you see in front of that name, there's a string. And then there's an equal to sign. And we have DG. Essentially what that is saying is that let there be a name that has a type. So the type of the name is a string. And what do we mean by types, really? We have different data types. I'll still come to that, but while we're here, I would like to explain briefly. We have different data types, and a variable can hold different kind of data types. So here we are saying that the data type that this variable is holding is a string, right? And then we are saying that string has a value, DG. For different programming languages, there are quirks to them. Well, let me even state it. We have programming languages that are strongly typed, and I will explain what that is. And we have programming languages that are not strongly typed, right? So when we say a programming language is strongly typed, I would like to take your mind back to when I said a programming language is a formal language. And then I was talking about the strictness of the syntax. So for a strongly typed programming language, is essentially saying that once you declare a variable to be a type, it continues to be that type and it doesn't change. But for a programming language that is not strongly typed, you can declare a variable and it won't require you to give it a type. And you can assign whatever value you have to that variable. So strongly typed, weakly typed, right? So that's that for variable. You will come across it all the time. Again, we are laying the foundation for you, and especially we are targeting those who might actually be coming into programming for the first time. We know that some of you are already building software Some of you are already building a website, but we also want to make accommodation for those who are just starting out. And for those of you who are already building a website, we also are trying to make or give you a solid foundation that you may have omitted. Yes, we get excited about building, and sometimes we skim through the basics. And in our opening class, I did mention something about the need for us to actually emphasize on learning the basics now. Yes, we have AI supported coding, and I've had a fair share of my experience using such tools to write codes. Yes, it does produce some good code, but the amount of value you get out of it is also dependent on your experience level and the level of knowledge that you have. How you prompt the AI to produce code is all going to be based on the knowledge that you have and the experience that you have, because there will be times that errors will be introduced, but because you are vastly experienced, you'll be able to spot it. And there will be times that the AI hallucinates, but because you already have a good knowledge of the foundation, you'll be able to spot it when it's hallucinating. I mean, I've been in a position where I wanted the AI to fix a bug, and it just kept on in a loop, reintroducing the same error. It will take it out in the next iteration and bring it back in another iteration. I mean, if I had no knowledge of what I'm doing, I'll just be stuck in that loop with it, right? So that's why it's important to cover the basics now. All right, so let's get to the next construct, which is operations. So we did talk about variables. Now, operation is action you perform on data. You can either perform arithmetic operation, you can do comparison, you can perform logical operation, and so on and so forth. So if you look at the code snippet that I added below it, this also is a TypeScript code. We're adding two numbers. We're adding 10 to 5. So we are saying let total, which is a number, like I explained earlier, total is of the type number, and we are saying it should have a value of 10 plus 5. So the eventual value will now be 15. This is an operation, right? And there are many other operations as well. Like I mentioned, you can do comparison. So you can say let total number equals 10 greater than 5. That will throw an error actually, because comparison should return a true t value. And what do I mean by true t value? It should either be true or false. So in that case, you would do something like let total be of type boolean. Boolean is true or false, and then you do your comparison, 10 greater than 5 or 10 equal to 5, and it will return a value. All right, for those asking for attendance, the attendance will happen around 8 o'clock, which is about 6 minutes from now. And I do hope that you are not just here for the attendance, that you are paying close attention. So do ensure that you are gaining value from the class. All right. So next we look at data types. I did mention in the first two constructs, talking about data types. So here we'll look at some basic data types. Integer. If you have a mathematical background, you understand what an integer is. And this is not to say that you need maths to be able to write code, but then it does help to understand mathematics a bit. And like I did mention, that programming is very much of mathematics, because when you write a function and you give it an input, you expect to get the same output out all the time. And that's how a function works in mathematics as well. When you say x is 2 and you throw a function at it, for every time x is 2, you should expect to get the same answer until x changes, right? So here I have a Python code. You see that it's different from the one we had in the previous slide, just slightly different, but it still carries the same meaning. In the previous slide, we were saying that let total be declared as a type number, and then we give it a value. But here in Python, you are stating the data type first, and then the variable name, and then value. But you get an idea that yes, there's always a type, there's always a variable name, and then there is a value assigned to that variable. Okay, so data types define the kind of values your variable can store. And the common ones, we have a Boolean. I mentioned what a Boolean is. It holds true or false. You have strings. So when you want to assign a text to a variable, say your name or the name of the location you're joining from, that would be a text. And then you have more complex types like list, dictionaries. I think in the third class for this week, we actually get to the point where you begin to write code. But we also want to be sure that you have your IDE set up already so that you can follow along with that class. So in the very next class, we'll cover as much as possible and try to help you set up your IDs. So try not to miss that class. So as I was saying, you have more complex types like lists and dictionaries, and those will be covered in a later class. So now we look at control structures. Control structures are conditionals and loops. Take your mind back to when I said you can perform operations such as comparison. In doing conditionals and loops, you heavily rely on comparison and then other operations like addition, right? So a control structure manages the flow of a program by allowing conditional execution and loops. So essentially what we are saying is when your code is running, you get to a point where you have to make a decision, and the decision you're making is based on a condition. So let's say, for instance, the code snippets attached in this slide. Well, you will get your slides soon, but bear with me. I will just read it out. I know some of you might not be able to see it. So in this code block, we have if age is greater than 18, then write on the console adult. Essentially, we are saying if the age of a person is greater than 18, the person is an adult, right? So that's a comparison being used in a conditional statement. And now you can see that with this conditional, you can actually break the flow of your program. So your program is already executing, but by the time it gets to this conditional that is being run, it can branch out to another aspect of the program you've written. So with this, you can control where your program goes to and how it is executed. And for loop, take for instance, you want to do something repeatedly over and over again. Instead of writing lines of code, let's say you want to copy a number 1,000,000 times. You won't say copy number and write it 1,000,000 times. I mean, that won't be a smart approach, but you can use a loop to actually do that. So in your loop condition, you set where it's going to start from and how it is to end and what condition it should be checking for to determine how that loop should end. So let's say you want to write out 1 to 1,000,000 now. You won't say, if you're using JavaScript, for instance, you won't say console log 1, console log 2. You can just put all of that inside a loop, and you start from 0 and until it gets to 1,000,000, and it just continues to run, right? And you see how smart that is, right? Okay, it's 8 o'clock now. I'm going to pause for us to do our attendance, and when we come back, we'll continue with the different constructs that we have in programming language. So watch out for watch out for the comment section and the description of the video you're watching, and you'll see the link to do your attendance there. All right, guys, you're welcome back. Once again, if you're just joining, good evening, good morning, good afternoon. I hope you were able to sign the attendance, but if you're finding it difficult to do, the link is right there in the video description. So what you have to do is click on the more. There's a more button on the page you're watching from, and you will see the link. It says to take your attendance, click here. So click on that and you should be able to take your attendance. All right, so we continue with the class. We stopped at control structures. We looked at conditionals and loop. And next we'll look at functions. We look at functions. And to reiterate, we are having this class to provide like a basis for the subsequent classes we'll be having. Again, we are giving consideration to those who might actually be picking up programming for the first time, or who are still very new to programming and who are still finding their way around programming. So what are functions? So functions, they group related code. They group them into reusable units. Like I was saying earlier, when you are doing maths, you write functions, and those functions are expected to do a specific thing. And those specific things they do, they are expected that whenever they get an input, they should give the same output always, right? They should give the same output always. So you define a function to do a specific task, then you call it whenever you need that task done. They make your code cleaner, more readable, and easier to debug. So let's say you have a function for drawing a circle. You know that in drawing a circle, you provide it with maybe the diameter of the circle you want, right? And it could also be that the function should be able to give your circle a color, right? So that has become a specific set of tasks. So whenever you need to draw a circle, you just call the function with the right parameters, and then it gives you an output. So functions are reusable blocks of code. They perform specific tasks. And if you look there, there's a snippet of code that shows you how to declare a function, or how to write a function. Now this function is has a name greet. It's showing you the type that the function returns, which is string. So the first string you're seeing there is showing you the type that it returns, and inside the parentheses it has a string name, and the name is the parameter it receives. So this function is expecting to get a value from outside. So when you're calling it and saying greet parentheses, then the name that you want it to print eventually. So in my case, I'll say greet Deji, and it will return hello Deji, right? So these other parts of the function, public, static, they are peculiar with with object-oriented programming. So we won't go into that yet, so as not to get people confused. But once we get to object-oriented programming class, we will describe what those are for. They are called access modifiers, right? And they start, well, let's get to the object-oriented class, and then we'll give a better definition and also talk about some of that concept in object-oriented programming. Now we talk about data structures. Again, we are looking at the different constructs that makes up a programming language. So we look at what a data structure is. So it's a way for you to organize multiple pieces of data efficiently. So now let's say you have a list of things that you want to do. Those are pieces of information. For every item you have in that list, it is a piece of information. Even that item on the list in itself has pieces of information, right? So how do you store all this information together? How do you organize them and have it organized in an efficient manner? By efficient manner, we mean after organizing it, you should be able to access the data efficiently. So this forms what we call data structures. And when we get to the class where we talk about algorithms, we'll go back to these data structures, because data structures also have a way of assessing them, have a way of modifying them, and sometimes have a way of analyzing them. And all of those forms the algorithm that a data structure carries, right? So in the example in the slide here, we have integer, but here is describing an array of integers. So that number is an array. What do we mean by array? So it's not just storing one value, it's storing several values. And the data structure has some algorithm about it in how you assess value from it. We also have other data structures like map, hash map, and so on and so forth. And different programming languages have their own way of describing data, right? But essentially all of them have the same concept around them. So once you're able to understand data structure, regardless of the programming language that you're working with, most of them, you see the same implementation of a data structure that you would have in one programming language, also available in other programming languages. The difference might now be how you use them, but essentially they're about the same thing. And thankfully, programming language or programming has matured to the point now where there are a lot of libraries and modules that are already pre-written. So most of these things you won't even get to write them yourself, because they've been written, fine-tuned, and they've been made performant as possible. So they have really high performance that you won't even have a need to write some of these things again, right? So data structures are critical for mapping complex data in a program, allowing you to organize and access information efficiently. So now let's look at input and output. Input and output. And well, I think it's worthy to mention again, because really for you just starting out, or for you who are just picking up a programming language, for whatever time you want to switch to another programming language, you can always come back to this construct, because you will find them elsewhere. You find them in a newer language that you want to learn. So the question now to yourself will be that, oh, I already know how to do this in, say for instance, Python. So how do they do it in Rust? How do they do it in C#? So if you already understand it in say Python, if you choose Python to be your first programming language, then learning it in another programming language won't be hard. And that's why the saying goes thus, that yes, learning your first programming language will be the most challenging, but subsequent languages will become easier, because you already understand this construct in other programming languages. All right, so when we talk about input and output for your program, as you're writing them, you would expect to get input from your users, and on that input, your code will process and then give out an output. So say you have a function that expects get a name. So you show your user, enter a name, and then it will collect input from the user. So you put your name, and then it will give you an output again. And this goes on and on. Sometimes input-output operation happens between systems, and there are times that input-output operations happens between human and the software. And for those who might be interested in web, when your user experience designer designs, they are basically designing an interface for your users to interact with whatever code you're going to be writing. So this snippet that we have here is really a user interface, because the user gets to interact with the program via that. So it might seem simple, but it's really a user interface. So we go to the next one, comments. Comments are very important, and knowing how to comment in different programming language also matters. Yes, you might say, oh, but it's just for the human being to know what's going on. Yes, those are really important, because even for you writing the code, you might come back to the code 2 days later thinking that, yes, I wrote the code, I will understand it when I come back to it. But 2 days later, you still have to struggle to understand what was earlier written, because you may have lost context to what code you wrote. Or, I mean, you might just have been in the spur of the moment when you're writing those codes. But it's a lot beneficial for you to have comments attached to your code. And also, much more advantageous to those working that will be working in a team, because other people will have to read your code. So it will be at an advantage when they can see the code that you've written and just look at the comments and get a basic understanding before going deep into the code. I mean, it helps. And also, comments are useful for IDs. So when you set up your IDE and you comment your code, it can actually help your IDE in helping you. So there are times that your IDE completes code for you, and it's able to do that because you commented your code in a kind of way, describing to it, for instance, what parameters a function is to expect and what output it's meant to give, right? So all of that helps you. And comments are universal in all programming languages. Well, as far as I know, comments are universal. Then we have classes and objects. But before I describe classes and objects, I will take a break to look at our comments in the comment section, and if there are any questions, for me to attend to. All right, we're talking about attendance. Okay. No questions that I can see so far. Okay, someone is asking what kind of job can they apply to after this training. So when we started, we did mention that we are going to provide you with knowledge enough that a junior developer should possess, right? But again, we know that we have a limitation of time, given that is 3 months. But with you cooperating with us as well, and with you giving in extra effort to learning on your own, I think you should be able to cover good ground to apply either as an intern or as a junior developer. Someone is asking, for blockchain game developer mobile app, do we still need to pass through the same training? So, yeah, to an extent, yes, because at the end of the day, whatever you're doing is really building software. Even the game you're building is a software, really. And the same principle that guides all kinds of software applies even for game development as well. So, yeah. Okay. Someone is asking a specific question about double and float. Well, I think we'll just leave all those particular details to the right classes. Let's cover what's really our main focus for now. Someone said comments are always ignored even in JavaScript. I don't know what that question is about. Someone is asking what an IDE is. Yeah, I said the next class will cover how to set up your IDE. So IDE is integrated development environment. Is all the set of tools that you use together in building software. For web, I think VS Code is sufficient, like I mentioned earlier. Someone is asking what programming language we'll be using. We want to try as much as possible to expose you to different programming languages. But for now, I think we are considering TypeScript for the next class. But if there'll be any changes to that, you will definitely know. But the focus or the aim really is to get you confident enough to the point where you'll be able to pick any programming language of your choice without us handholding you. But having gotten the basics, you can go ahead and kickstart the journey of actually learning by yourself. All right, so let's continue to classes and objects. And once we do that, we'll look at modules and libraries and error handling. And then we take a break to see if there are questions that we need to answer regarding those topics. All right, so talking about classes, I did describe earlier that it's a way for us to model real life objects, which provides a platform, if you call it that, or which enables us to actually begin to write even much more complex problems, because the problems that you tackle in software development are really close to human as possible. So they are like objects that you're dealing with. So let's say, for instance, you are writing a program for a bank, and what the bank wants to be able to do is check credit scores for people, right? The people that you'll be checking credit scores for, they have attributes. And one of the attributes that you might consider in such a situation is, okay, how do they assess loan? How often do they get loans? And how often do they pay back? And how much debt do they have? All of these are attributes that can be associated to a person. So it becomes a lot easier if you have a programming language that can allow you do a modeling that is as close to that. So a person has a credit score, a person has a loan unpaid, a person has a debt, a person has so much in their bank account. All these are attributes to a person. So using classes and objects, it helps us to actually model as close as possible and the real world in the programs that we are writing. So a class defines a blueprint, like a template, and an object is a specific instance of that blueprint. In the code snippet, you see a person and there's a constructor. So that person, that class person and all of that in the curly braces, that is a class. But when you now instantiate it, now different programming languages have how they do this. But when you instantiate, when we say instantiate, when you create an instance of that class, like we have in the last line in that code snippet where we have let p equals new percentage, right? That p is now an object. So there's a blueprint or a template of how the object should behave. Then when you create an instance from that template, you now have an object really. Okay, so I will just go ahead because we have a class dedicated to object-oriented programming specifically. So let's talk about modules and libraries. Earlier when I was talking about your choice of programming language, I did mention that there should be an ecosystem. You should really consider the ecosystem that is surrounding the programming language that you have. And the ecosystem also includes what libraries have been written, what modules are available, because as you're writing your code, you are not going to be writing everything from scratch. I mean, it's not effective for you to write everything from scratch. People have already written some really cool functions. They already created some really cool libraries that you can just rely on. And I think that's one thing that makes Python really popular, because it has a lot of library that are targeted towards some specific problem, and it has a lot of it. And I also think that that's why JavaScript and TypeScript, or the Node ecosystem, is also popular, because there's a lot of package already written. And similar thing for PHP, you have a lot of composer packages already written that you can easily use to build whatever software you're building. So modules and libraries let you reuse codes written by others. So you import the module into your own code, and you can call different functions from the modules, right? And that's what we see in different programming languages. So for Java, for instance, you can import different modules. For TypeScript also, you can import modules that will help fast track what you're building. All right, then we talk about error handling lastly for this section of the class. Again, why we're talking about all this is for us to know those things that repeat itself, or those things that are common to all programming languages. So error handling is also common to most recent programming languages, right? How to handle error when they happen. So error handling involves managing and responding to runtime errors to prevent the program from crashing. So if you don't handle error and you allow your program to run, if there's an error that happens, it can lead to the program crashing. But if you handle the error properly, and by handling, I mean that you caught the error and respond appropriately, it will allow your program continue to run, even if it does encounter errors. So by anticipating and catching errors, you can provide meaningful feedback to users and ensure the program runs smoothly. So if your user encounter an error while they're using the program, so that they won't be lost as to what is going on, right? You should provide them with error responses that will explain to them that this is what happened as they were using the program. So different programming languages have how they handle that. For Java, you see that code block. That's a typical example of how to do error handling in Java. Then Python, you use a try and except in Python, and you get your error handled. All right, so I'll pause for a minute. If there are any questions regarding all of this that we've talked about, I will go through the comment section to see if I can answer them. And once we're done, once we're done with that, we'll come to how programs are run. How do you run your program? And then I'll go back to the different kind of programming languages that we have, and how that impacts running them. All right, some people are already talking about TXS and JSX. That's nice. That shows that you have some knowledge already, which is good. Okay. Someone said they are not even understanding anything. Well, I do hope that when you go back to the video, at your own leisure, just take your time to listen again. And once you get the slides as well, I believe that will help you to understand better. And then in subsequent classes, we will still refer to some of these things that I'm talking about here, so that should help you. Someone asked if comments are ignored in JavaScript. Well, I wouldn't understand fully what you're asking, but I want to believe that you are asking if comments are run as part of the code. No, comments are ignored. Yes, when you're running your code, JavaScript does not. The JavaScript engine does not count comment as executable code. Yeah, someone says they love TypeScript. That's nice. Yeah, I like TypeScript as well myself. Someone is asking what IDE is again. IDE is Integrated Development Environment, and that's what you use to write your code. So it's like a text editor, but much more than a text editor. Someone is asking where is a place to comment in a code considering HTML and CSS. Yeah, you can comment anywhere in the code. Okay. All right. Okay. Someone is asking what's so I'm guessing the question is what about Python with the most extensive libraries that are easy to. Okay. I'm guessing the question is what libraries should they install? Well, it's depending on what you want to do. So you find the library that fits what you're trying to achieve. I know there are suites of libraries that people use generally. So, say for instance, you're doing data science or anything related to data. Yeah, there are some suites of libraries that are recommended for those. But yes, it still boils down to you figuring out what you intend to achieve with what you're doing, and then finding the right library for that. Someone is asking what's the difference between programming languages and libraries. That's a good question. So a programming language, like we described, allows you to instruct a computer, but then a library contains already pre-written code. So still in a particular programming language. So let's say, for instance, JavaScript. JavaScript is a programming language, but a library written in JavaScript contains a set of code targeted at a specific task. So library is still written in a programming language, right? So a typical library might be a library that helps you figure out the time of the day. A library that helps you deal with dates. So, I mean, those are typical problem with programming language that we come across every day. So a library does exist for them, so that you don't have to rewrite your own method for handling something as trivial and repetitive as how do you deal with dates? How do you find the difference between 2 days, right? So that's why libraries exist. Someone is asking what debugging is. Well, not really related to this class. I think we'll get to debugging. Yeah, I think during IDE we'll talk a bit about debugging, but also in another class we specifically focus on how to debug your code. So debugging is actually figuring out the error that may be happening in your code, essentially. All right. Someone is asking if we are going to be doing real life projects during the class. Yes, we will do real life projects, and I think you'll be the one to actually choose the project that you want to work on. But definitely we'll be building a full stack project. All right, so we'll get back to the class. We stopped at error handling, and now we'll go to the next part of the class, how programs are run. Depending on language, you can either compile a code, or the code can be interpreted, or the code can be transpiled. And I will explain what all of this means. There are some languages that when you're working with them, they have to be compiled. And the process of compilation is to sort of transform the code into a form that a computer can readily understand. I mean, that's a layman way of explaining it. There's so much more that goes into that. But the whole idea is when you write your code, it goes through the process of compilation, and then it gives you an output. That output is what you run, right? So you start with the source code, then you compile it. So compiling means that you are transforming it into another form that a computer can easily run, right? But for interpreted languages or interpreted programming languages, your code is read and executed line by line. So the way you wrote it is the way it's going to be executed. So let's say you say add 1 to 3. It's going to read it as add 1 to 3 and execute it line by line like that. So it doesn't have a compiled form. Just as you wrote it is how it's going to interpret it real time. So the code is read and executed line by line at runtime by an interpreter. So there's an interpreter that does all of that. Fine, it is slower, but it's also good for scripting. Like imagine where you want to be able to quickly change things in your code and you have to wait for compilation, which sometimes do run into minutes. I mean, depending on how big your program is, just because you want to change a value. But also it has its own benefit in that once it is compiled and compiled to a machine readable form, it tends to be faster because the interaction that happens in between the code and the machine is faster as against an interpreter being in between. I mean, just think about you talking to someone who doesn't understand your language. It takes twice as more for an interpreter to listen to you and then interpret to the other person. So it tends to be slower, but it has its own benefits, especially when you are prototyping and you need to keep changing things. I mean, it's what is characterized of today's software development landscape, where most of the software we are building is being run on the web. And really, hardly can you compile a software for the web. Yes, I mean, there are situations where, or there are instances where you're able to compile for the web, but in most cases, with most programming language that we have today, or with most framework that we have today, they are mostly interpreted. Then we talk about transpilation, which is typical with TypeScript. So transpilation is not really compilation, but you are translating from one level of programming language down to another level of programming language. So for TypeScript, for instance, is a superscript of JavaScript. What do I mean by that? TypeScript builds on top of JavaScript. You know, I was saying earlier that there are programming languages that are strongly typed and there are programming languages that are not strongly typed. So TypeScript is a version of JavaScript that is typed, that has a type, right? So for your browser to be able to understand what you've written in TypeScript, there needs to be a transpilation from TypeScript to JavaScript. Well, all of this you get to really understand by the time we start writing code, but I thought to put this as part of this class so that when we get to that point, we won't be lost as to what we mean by compilation or interpreted or transpilation. All right. So we will end this class with programming paradigms. And this I will touch on briefly, but it's all to the end that we gain good understanding of different programming languages and how to approach them. I've talked extensively about object-oriented programming, even though I didn't go into full details, but I've cited a couple of examples. So object-oriented programming is a programming paradigm, is an approach to programming in itself. Okay, so what are programming paradigm? A programming paradigm is a relatively high-level way to conceptualize and structure the implementation of a computer program. You know, I was saying earlier that object-oriented programming allows us now to be able to write much more complex code in a safer manner. And why are we able to write much more complex code in a safer manner? Because we know that when the code is running, there won't be an error due to type mismatch. That's for one. We also know that it's going to be secured because of how object-oriented programming works. So that's a way to think about that as a paradigm for building software, or a paradigm for writing code in object-oriented programming. It offers its benefits, right? And other paradigms also offer their benefit. They have their plus. And remember when I said earlier that when you're choosing your programming language, it's also depending on the learning curve to it. For some people, when they start object-oriented programming, it's very confusing for them. While some people find it easy to understand because it mimics real-life objects. I mean, by the time you start talking about encapsulation and all of that, some people get lost in the way. But all of these program paradigms and approaches to programming, yeah, on the plus side, it provides us with different entry points into programming. If you find imperative programming easier, yes, that might be your entry point into programming before you now move further into other paradigms. And I also did mention that nowadays, modern programming languages are multi-paradigm, which means the same programming language you can use for different type of programming approaches. So for instance, now you can use Python for functional programming, which is also the same thing as procedural, by the way. And you can also use it for object-oriented programming. You can use it for imperative programming as well, which is a plus, which means you just need to learn a single language and you can have different approaches to solving the problem that you have at hand. All right, I have some code snippet here that just shows the differences between how programming languages or programming paradigms approach to solve a problem. So in the first one, it's imperative, which just describes line by line how a problem should be solved. And then we have a functional program. And when I was describing function earlier, I said a function combines together the same set of functionalities or the same set of use case and allows you to be able to send a parameter to it for you to get an output out of it. So essentially what that means is that you group together a set of code under a name, and then you can call that function over and over again, keeping your code clean. So there's a program paradigm that approaches solving problem in that way, that you must have functions defined for things. So you want to greet, you should have a function for greet. You want to display a message, you should have a function to display a message. So that's a paradigm. Then we come to object-oriented programming, which define things in classes. So classes have actions, classes have properties. Like one action might be that a car can run, or one action might be that an animal is able to speak. And a property might be that, oh, the animal has 2 legs, right? So those are different approaches to writing programs. Well, someone might be asking which is the best approach. It's all depending. Say, for instance, object-oriented programming, it has some rules guiding it. Well, if I might call it rules, it has some rules guiding it, and it has some concepts around it as well. When we get to object-oriented programming, we will talk about solid principles, for instance, which are like some set of rules that you should consider when you're building, when you're doing object-oriented programming. So in that case, there's a level of design that needs to happen earlier on before you start implementing. And that might be a bottleneck for some people because they don't know all that needs to happen in the code. All is not yet defined yet. So for such a person, they might find it a lot easier for them to just write simple functions as against writing a class. I mean, the trade-off is not a lot. The savings also is not a lot. So the time that it will take you to write an object-oriented class, or the time it will take you to write a class might actually be the same time it will take you to write a function, but it's all depending on the amount of information you have ahead of time. And I have here declarative programming. Like, just to give a contrast, there are some problems that you can't loop through. For instance, I was citing an example of HTML. In HTML, you don't assign variables. You don't do if else. Yes, although in some augmented HTML, let's say in React, you're able to do all of that. But in the raw form of HTML, you are mostly declaring what you want to see. So you declare that this part should be blue, this part should be red. Also, CSS is declarative because you are declaring that a value, an option should hold a value. Same thing with SQL. You are declaring what should happen without necessarily writing imperatively what should happen. So you are declaring that, for instance, you want to select from the table users, you want to select all columns from table users where age is greater than 25. You are not telling the database how you should figure out that age is greater than 25. You are just saying to it that this is what I want you to give me back. So that's what I mean by declarative. All right, so imperative tells the computer what to do step by step, and the focus is how to do it, while declarative programming tells the computer what you want, not exactly how to do it. For object-oriented programming, you are modeling a real-world object with properties and behavior. And then for functional programming, you are using functions, right, to program what you want to program. All right, so I'll give us the next 10 minutes to ask our questions. So if there be any questions from what we've talked about so far. And if I was a bit fast, I'm sorry, I was trying to cover good ground today, given the time that we have, and there's so many things that we actually need to cover. So I will be looking at our chart in the next couple of minutes before the class comes to an end. So if there are any question about the class, question about this particular class, question about the course itself, you can ask them now. Yes, about the slides, you get them. By the way, when we started today's class, I did give some information. So for some people who were not here when we started, I mentioned that we'll be having a weekly assessment going forward. So the weekly assessment is to actually help us crystallize the information we've gotten. And you might notice that we are getting faster with with the classes now, because indeed we have a lot to cover, and for you to be able to say, yes, I did learn software development and these are the things that I learned. There's indeed a lot to learn. And like someone was asking earlier, what kind of role or job would they be able to get after this class? Yes, you'll be able to land a junior dev role, or you'll be able to land an internship role. But all of that is dependent on how much knowledge you're able to retain and how much you're able to apply yourself to what we are teaching you here. So there will be weekly assessment, like I mentioned, and we'll provide links every Friday for you to do your assessment. I will give you 1 week to submit it. So once the link is provided on Friday, we are expecting that before the next Friday, you should have done them and submitted, because before the class on Friday, the link to the assessments won't be available anymore. All right. So looking through our chat so far, I have a couple of questions. Someone is asking, can VS Code be used to build apps? Well, not VS Code alone, coupled with other things, but it's also depending what apps are you trying to build. If it's mobile app, yes, you can write the code in VS Code. You can run the script that will compile the code all from VS Code, but not just with VS Code alone. Someone is asking, please let's start practical early. Can't wait. Yeah, don't worry, we'll get to that. Someone is asking, are there pre-written? Okay, they are pre-written codes that you can use without. I guess that's an answer to an earlier question, which is good. Yes, they are pre-written codes. Libraries are pre-written codes that you can use without writing from scratch. Good answer. Can we use other IDs like PyCharm or Anaconda Navigator? Yes, those are good, but depending on how the class goes, I think we might all be leaning towards VS Code so that it's uniform, really, and if there are issues, you can easily resolve them. Yeah, regarding programming language, I did mention that it might be any. It could be PHP, it could be TypeScript. Really, software development is really programming language agnostic, and what we are trying to achieve is that at the end of this course, you actually have the right knowledge, not really about a programming language, but you have the right knowledge to help you even pick up any programming language and learn by yourself. But for this class, we are already considering TypeScript. We also are giving consideration to PHP. And if it so happens, we might do Java. But we'll let you know all of that once we get to the point. Someone asked, which platform can I get the 100 days of coding in JS? I think there is one in Free Code Camp. Yeah, but you can just Google, you should be able to find some. So it contains like codes for 100 days, targeting different problems. So you are writing code every day. Yeah, regarding tools that we need, as the classes approaches, we will let you know, right? Someone said they saw a job role today for full stack developer. The pay was the full stack developer, the pay was 1.5 million naira per month. Yeah, yes, it is true. If you're wondering if it's true or not, it is true. And people get more than that as well. People get times 10 if you're that good. So when someone says is a DevOps, does he also code? Yes. There are instances where you need to write code. You might be writing a bash script, or you still code in one way or the other. Okay, I already answered the question about the language we learned for the class. And thank you for your kind words. Israel Alalade. I don't know if I'm pronouncing the name right. Someone is asking, can we use our phone to write code? I mean, to do practical aspects. Yes, you can, but it won't be as convenient as having a laptop. All right, all right. Thank you all for your kind words. And at this point, we come to the end of this class. Our next class, we'll be looking at integrated development environment, like I did mention. That class will be a bit of a practical as well. We'll try to make it as practical as possible. But in order to help you, we'll be focusing fully on VS Code. I think that is universal enough, like I mentioned. So before the class, you can do well to download it so that if it's possible, you can also follow along as the class progresses. So the next class we're looking at IDs. All right, for those who are asking when we'll get into practical, this week definitely you begin to see some practicals. All right, so that's it from my own end. Once again, it's nice having you guys around tonight, and from wherever we may be joining. If it's afternoon, it's good to have you, and we look forward to meeting you again in the next class. Do have a wonderful day.